Hi, I'm Dr. Tiffany Barnes. I'm an Associate Professor of Computer Science at North Carolina State University. And we have a Center of Educational Informatics, the first one in the country, that seeks to use computer science to improve education, both through building educational games and by applying artificial intelligence techniques to data in education environments.
So it is my great pleasure to introduce today Tiffany Barnes. She's a well-known researcher in the area of educational data mining, one of the leaders in the area, one of the co-chairs and chairs of the conference, and also one of the major researchers in the area of serious games and games for learning. She's an associate professor with the North State Carolina University. Tiffany, could you please tell us a bit more about your research in learning analytics and what kind of things you are doing in learning analytics?
One of our biggest advances in my lab was the idea of taking individual student experiences, their data from interaction data from a procedural problem-solving environment, and putting that into a large graph of all of the students' experiences, all the steps that they take when they're solving problems, and then using those steps in that graph to then look at a new student who comes along, match them to someone who's done the problem solving in exactly the same way, and then use that as a source of domain knowledge that we could use to give hints to new students. And we've actually built that into a system for students in college learning logic proofs in a discrete math class, and shown that students who have these automatically generated hints based on peeking at someone else's homework are 3.5 times more likely to finish the tutor that we have for them. And they finish it in 45% less time. But I'm also interested from a perspective of how do we also use that data not only to give feedback to individual students, but also to let us know about the system itself. So you can also look and see, when you look at this data of what students have done in a learning environment, you can identify places where many people are having the same errors, and these are places where you could point out to teachers or to the tutor developer that this needs to be changed.
Thanks very much. That sounds very exciting. A lot of different aspects of learning, a lot of different environments that you are looking into. Can you tell us a bit more about the types of methods and techniques and tools that you are using in your research so that you can get better and deeper insight into learning?
So most of the approaches that I've been using lately are using graph-based methods where we take the data that's coming from an environment, a virtual environment, and map it into states. And you can think of these states as like a screenshot of what's going on in a problem-solving environment where everything that's been done up to now, including the problem description, is on the screen. And I basically take a screenshot of that. And then our graph-based approach is to have each student's path of work be like a series of screenshots with arrows in between them, where the arrows are the action that they've taken that takes them from one state to the next. And with that kind of general representation, you can actually think about interactive experiences not only in a learning environment, but also in a gaming environment. And then once we have our graphs, we've been using tools like R to analyze the data that we can extract. So we'll get things into a graph representation and then extract them into a file, just Excel or something, and then do CSV parsing of that with R, and then running analysis. So that's mostly what we're using right now is R. But we also have our own visualization platform that we've built called NViz, which will take interaction data and put it into a graph that you can search and analyze. And we've built some summarization techniques for those graphical representations of sequences of actions in a learning environment.
That sounds very exciting and interesting. So could you tell us a bit more about the types of insights you are getting with these types of techniques, and especially in comparison to the traditional techniques that are used in educational research and learning sciences?
One of the latest methods that we have used is to apply survival analysis to student data, like their time and completion data in a tutor. And the reason why we did that is because when we added our hints to our system, we were actually seeing that students were less likely to drop out of our tutor if they had hints. But that means that we had a lot of people in the control group that were dropping out. So when we tried to compare the time to solve problems between our experimental and control groups, we couldn't do it because the control group had so few people that were completing that when we looked at the times, it wasn't telling us any interesting information. So we looked to the medical field that studies medicines and medical and surgical approaches and tries to understand, what is the impact on survival of this technique. That's what we started looking at to try to model and understand what students were doing. So what this basically does is it tries to estimate for given populations in your study, how long would they take if they did, stick out through the whole thing. So we can estimate, we've been able to estimate that students who were in our control group basically take more time to solve problems in the tutor, and we got a multiplication factor so that we know students with hints take 0.45 or 45% of the time that control group students do. So, like I said, we've had insights along the line of design of tutors, insights along, whether or not past data from students can help new students, and it wouldn't be possible without learning analytics.
Thank you very much for sharing your time and your insights and experience in learning analytics, and we look forward to learning more about your future research.